Hello.
Hello.
Hi.
Hi, many greetings, dear. Uh, Many greetings to you. I'm also speaking.
Okay, I'm Tabor. You're the one you reached out to on LinkedIn.
Uh, you know, I'm learning to use this. I wish I would be able to put my face also.
There's a button for video.
Okay, okay, okay.
There you go.
All right, all right. Thank you so much, dear Tabo. Greetings,
And
greetings.
and what's your name?
My names are Mumba Oswald Onenchan.
Omamba Onencha.
Onenchan, yeah. I'm called Onenchan. The easiest one is that. Or Oswald. Oswald.
Oswald.
Oswald, yes.
All right. I have transcription on here so I can read what you're pronouncing. It seems to spell correctly, I hope. But if there's any language challenge, just slow us down and try to ask me what you're if I talk too fast, let me know.
Oh,
Um,
yeah.
but what I guess like my first question for you is what was most interesting for you to want to reach out to me? What were you excited to learn?
Sure. I briefly can
Mhm.
give you the profile of our farm and I get to where we would like to go. To go. Mamo Gardens model farm, we formed this garden in 2016 and it is going to date. We are
Great.
20 members who contributed land. We contributed land with the aim of coming together. Each one contributed land and we contributed to 20 acres of land. That is 9 hectares. In this farming, we are doing agroforestry. We are planting fruits, vegetables. We are rearing chicken. We have few goats. We have 7 goats, and we would like to add the numbers of cows. We have 4 cows. We are a registered group. We felt we should register it so that we could form an association where I'm the director. I'm the director. So we have a
You're the director.
presentation of, yes, I'm the director. And we have a presentation of this farm which we have written. So our success is we are producing food. We are producing wine from grapes because we have grown grapes on our farm. We have fruits where we would like to produce juice. We want to add value to our fruits because we would lose it at cheaper prices. But if we make juice and we sell, we are able to get money. We are rearing chicken at the moment, and it has been 1 year our chicken project is sitting.
Okay.
Indeed, our success goes as far as the government is getting concerned to come and train farmer communities surrounding us. We are proud of that because we are showing them what we do. And we have proved that unity is strength.
Hmm. Hmm.
We cast rain, though it's twice in a year, you find we have dry period.
Hmm.
Like now up to March, it is dry period, but April starts rainfall. Up July, it is dry period. So this brings us challenges in our group. We are looking forward to drill a pump where we can pump our water using solar. This will go to our seedlings and a kitchen garden for vegetables. And we are looking forward to buy cows and goats. I really got interested in you. I'm proud to mention this because biochar, biochar,
Biochar.
biochar is the nearest method to manage our fertile soil,
Mm-hmm.
and this is intended to increase our yield when we make proper use of biochar. This thing we did not know, and it is true. Farming is we feel we are traditionally farming, but we would like to take steps forward to know these things. Especially when I was reading about biochar, I found it is the most free natural nutrients we can put to our soil. And
An available
if it is,
resource.
yes, if it is got from trees, we have trees which we can convert into biochar, not only from our farm, but our contributions is much in terms of trees where we can cut and we make biochar. And I got more interested in the second area where I saw that you are doing you are rationally grazing to sequester
Yeah.
carbon. So
Yeah.
our chicken, our goats, and our cows, on a small scale, it will not go too soon. But in the longer run, when we do this, I am sure soil management is the first step to produce any kind of food if we are supposed to see us. I'm very proud of meeting you,
I'm
especially
honored
in my.
to meet you. I really appreciate you reaching out, and I appreciate your introduction, and thank you for sharing what you're doing. It's inspiring. I think it's amazing. You are absolutely right on so many fronts. Coming together as a community is the solution. It is our strength. It is our power. It's where we've come from, and it's where industry and society has pushed away the village and pushed away community because they wanted control and money, I guess. I don't know, but we're screwed up. And the solution is biochar is the base for me. That's to me when I discovered biochar, it invigorated me. I felt alive. I felt I was struggling in America as an American. I'm ashamed of my nation of people and the devastation of our ecosystems and our participation in it and my negligence to just basically do nothing and allow it because I was a child of this country. And I grew up with an eco depression. I can't solve this problem of the world's catastrophe. That's the feeling of depression I had. It was not about any one thing, it's about a whole ecosystem issue. And when I first read the book Terra Preta, and all the books I've read that inspired us are in our on our website, biocharcoalition.org is a list of reading material, which is every book we've read and our stand beside, even though not all of them are biochar related. But I read the book Terra Preta, and it was written by Kathleen Draper. And I've since met her. She's a wonderful woman, and she made it very clear that it is not her story. It is not her book. She's just authored it because um, the authors have since passed away. I have a cat here knocking at the door. Come on in. And so she's not the true author of the book. She says that from the get-go. That's why there's multiple authors, and the people who are the authors are basically what is it? They're soil people. They're archaeologists. They were digging in the ground trying to understand ancient people 2,000 years ago and how they lived. And the 2,000 years is something that they discovered. That's how long ago it was. That was part of their archaeological discovery, is that these were methodologies based on 2,000-year-old traditions. And after reading this very thin book, the first one that was published with the word biochar, by the time I finished reading the book, my life had been changed. And I hadn't even finished the book. And when I made my first pile of biochar and I saw this physical black substance and I knew what it was, it gave me relief to my ecological depression because it was a tangible substance, a material that we made, that I made it. It was physically there in front of me. It was measurable, I could eat it, like I could I could touch it. It was a beautiful sound to hear fresh biochar. It's like a crystal porcelain, very frail and lightweight, and it sounds just a beautiful sound to listen to them crumbling. And I felt huge relief. I can't believe it. I've never had that before. But when I made my second pile, I no longer had that feeling. It was degraded. It was like, look at how tiny this pile is. It's so little, it seemed insignificant because my neighbors were burning smoke and ash. They weren't making biochar. And what I evolved into is going door to door to neighbors and just telling them about biochar. At first, I would convince them to please come to my workshop. We're going to do a demonstration. I'll show you how to do it. They wouldn't come. I don't do that. I don't waste my time inviting them somewhere. If they want to come, they can come. They'll know what's going on. I welcome them, but I give them a lecture. Any person I meet, I give them this lecture. It's very simple. And I can go on for hours and we can digress in any direction you want in this conversation. But the basis of everything is going to come down to carbon. Carbon is the basis of all life. Everything, plant, animal, tree, rock, all things are 50% carbon. The whole body is 50% carbon. Now, in the plant's life cycle, in its living, breathing life cycle, a plant, I use a tree as a large example, but it's the same with the grass blade. In its entire life cycle, half of the carbon that it is inhaling from the air as carbon dioxide, because of the leaves, are photosynthesis. That photosynthesis generates electricity, which breaks off the carbon from the two oxygen, and the two oxygen go back out into the air as an exhale of the leaf, and is why the plants produce oxygen rich air because they're pulling the carbon off of carbon dioxide and even carbon monoxide for that matter. But they're removing the carbon from the oxygen and releasing the oxygen. So that carbon is now in the sugar of the plant, the sap, the juices, the veins, the nectar, everything within the cells and veins of the plant. That's where that carbon from the carbon dioxide ends up, is in that sugar flow. In the life cycle of all plants, half of all of the carbon that they inhale from their leaves and the oxygen released, that carbon is now released, half of it, through the root system. It's called an exude. It's a sugar sap. It's leaking out of the vein of the root. It's helping lubricate the trail that the root is growing, and it is feeding soil life, but it is feeding most intendedly, mycelium has evolved to live off of that exude. The mycelium, if you're not yet familiar, is the root of a mushroom as a simplified summary. But there's billions of types of mycelium as there are millions of types of mushrooms. There's different colors, and our mycelium is different than your mycelium. So you need to cultivate the mycelium in your ecosystem because it's evolved to survive in your ecosystem. It's what you'll find when you peel into your compost or decomposing cardboard. You'll see those veins of white, streaks, lines, like little thin threads. Those veins, those threads, that's mycelium. So it's a carbon life form. It needs carbon, but no mushroom nor mycelium has any photosynthesis. There's no leaf. They make a mushroom, which is the fruiting body, but they don't have a leaf. Because there's no leaf, they can't generate photosynthesis to get the electricity to pull the carbon out of the atmosphere. So to get the carbon, it has to break down something in the soil, decomposing wood, or most preferably, the easiest kind is the exude, the sap, the sugar that's leaking out of the root of the plant. It then takes that sugar, that carbon rich syrup, it grows its vein longer, it stretches further and easier than the roots can go to get access to more water and more nutrients. So the more mycelium you have across your landscape and soil, the richer your water and nutrient is able to move between it. It's going to go where it needs to go. So the living plant is like a magnetic generator. It is pulling in what it needs. It needs water. It needs that's hydrogen and oxygen. It needs sulfur and it needs nitrogen. It needs potassium and phosphorus and all these nutrients. It's pulling it in through a magnetical charge. What plants don't need are toxins and pharmaceuticals and pesticides and heavy metals. It doesn't need those things. It's not asking for them. Some plants maybe, like sulfur is a metal, that the mineral that they might be needing, but they're not needing mercury as an example, or lead. And those are elements that are in our ecosystem at this point. In ours especially, we got that mining history that led to mercury across landscapes. So the mercury is in the watershed. If it's in the water, if these elements are in the water, a plant sucks it up because it needed the hydrogen and the oxygen of the water, and by default it takes up these minerals, that heavy metals, these unwanted. If you have toxic soil, you have toxic food, right? So if you have a toxic soil issue, hemp is the fastest growing cannabis, same plant. It's the fastest growing annual on the planet. It grows from a tiny little seed to a ginormous 20-foot tower if you've nutrient enriched it. And it can grow close together for ropes or spread far apart for flowers and seeds to get more seed crop, which means you could use it for a chicken food crop. Now, the thing about it is it's going to suck up all those toxins. It's going to suck up all those minerals and all the elements if you're trying to clean up to take a landscape that has a problem on it, an unwanted uh, constituency and something, lead paint is there or whatever. You can suck it up into this plant. But now you don't want to go eating that plant. You don't want to go feeding that seed to the chicken in that case because you don't want to give them the lead. But if you take that and you carbonize it into charcoal, you're going to lock it up. It's going to get locked into the charcoal. So charcoal is 95% carbon. Carbon is the basis of all life, but it is a negative polarity in chemistry. It's a negative magnet. Anything positive will stick to it. Nitrogen, the most needed nutrient in our landscape, is positive polarity. It is immediately attracted to the carbon negative polarity. And the carbon molecule can hold 17 times its mass in nitrogen because nitrogen can touch nitrogen as well. Oxygen can stick to the nitrogen. Like, it's amazing. And the quickest way to get nitrogen is your urine, your cow's urine, your chicken's urine. The chicken urine is that white stuff on the shit. So they're kind of not separatable. But the idea is that urine is a great source of nitrogen, which therefore, wherever you're going to pee, do it on a pile of charcoal from now on. Some people will have a bucket and that's what I have. I have a bucket. So it's near where I need to pee. And then I can carry the bucket where I want to go distribute it. I would never again plant anything if there wasn't charcoal in the ground because of the clear advantages it creates. My neighbor was planting trees a few years ago, and I was there, and I had a bucket of pea char, and I went over there, and it was a little humiliating. They didn't even want to know, they didn't want to smell it, and I just didn't even tell them until the bucket was already being poured in the hole. I was like, "Oh, it's just a urine enriched charcoal I sell them," as I'm pouring it in the hole. Those are the only trees and rose bushes that survived. The rest of the trees they planted after I left have all subsequently died because of inadequate water or too dry of a summer heat, and they were a freshly planted tree that came from an overly watered nursery. So they now are convinced and will never plant a tree without some of my pea char. So I made them a pile of charcoal. Now they just have to go pee on it. If you got dogs that are always peeing in the same spot, go put the charcoal where they're pee. As a matter of fact, my cat goes to the pile. When I make a fresh pile of charcoal, that's where my cat goes. Anytime you make a pile of charcoal, I've seen wildlife and domestic life gravitate towards it. Now, there's mixed messages about eating it. we can get into some of that. But I want to get back to the basis of the carbon story to help you understand how anything can be made into biochar. Anything that will burn can be. I've done cardboard biochar, paper biochar, oak biochar, pine biochar, hemp biochar, cornstalk biochar, pine cone biochar, pine needle biochar. It doesn't matter what you have. If it is cellular structured, it can be made into biochar. That includes dead animals. I throw my bones into there. Now, bones won't in themselves become a fire, but if they are put into the condition of the heat of the fire, they will carbonize, but they will stay white because bone is full of calcium. So now you're keeping that calcium in your soil, but making it bioavailable because now it's a brittle carbonized cell structure. So
Good.
now I have a few variables that people get confused on, and I've been practicing to try to be articulate to help it understand. When I spoke about the tree and it had 50% of the carbon it inhaled has been released through the roots into the living soil, mostly through the mycelium realm. In exchange, the mycelium brings it water and nutrients, right? So that's 50% of the living life cycle, from seed to death. 50% of all inhaled carbon is released from the plant. I am no longer going to talk about that because as soon as your tree is dead or dies, if it dies on its own or you cut it down and killed it, it doesn't matter to me. Now I'm going to refer to it as a carcass. The living tree released 50%, it's over. Now we have a carcass of that tree or corn stalk or tomato plant. Those plant residues, the carcass residues, 50% of that matter. And I'm assuming everything above ground because when you cut the tree, usually you leave the root in the ground. And a corn stalk, you can pull the root out, but ultimately it's whatever. If you pulled your tree, I mean, out here they pull orchards with machines that lift whole trees out of the ground. It's crazy. But if you pull the whole tree out of the ground, then that's the whole carcass I'm talking about. Otherwise, the above ground that you cut, that's your carcass, and the root is just left to be the root. It is the same math, though. Whatever the root is left behind or whatever the above is the same. The dead carcass is 50% carbon. The total body is 50% carbon substance. Now, I'm going to divide that in half. This is not by making this up. This is science that I have memorized. And it's a average. I think that some plants may have variables of variation by a degree or a percent, but it's a good accuracy. 25% of the whole carcass, that's half of the carbon, right? There's 50% carbon. Of that 50% carbon, half of it, 25% total mass, is the cell wall. It is the structure of your home. The frame of the house is the cell wall, right? Everything inside the cell wall that fills it up with content that was once the living sugar and sap of the tree, it's now inside each cell. Each cell is filled with substance. It's the sugar content that is the other 25% of the plant's carbon. Okay, so there's two places carbon exists: the cell wall and the cell sugar content. Now, the cell wall has another element that's uh, hydrogen. Hydrogen is the element that is like the glue between the carbon. So the carbon is your brick of a home, and the hydrogen is the mortar in between the brick. Right? So you mainly have a wall of carbon, but you have a thin veil of hydrogen helping glue the carbon together and giving it the structure. Now, all life has this fact of 50% carbon, half of its cell wall, half of its cell sugar content. Now, what's different is the other 50% of what that plant is made of. because every plant is different. So they have a different chemistry of sulfur, of potassium, of phosphorus, of nitrogen. And they also have a different cell structure. And you can view this yourself with your naked eye on some things, and you can get excited with a microscope and really see the in-depth variances. But if you hold a leaf up in the light and you look through it, you can see the cell structure. You can see the little shapes of individual cells. Those cells are dictated by the genetics of that plant. So a willow plant is evolved for water. It sucks water up and puts it into a long veining branch that goes up and grows quickly, but it needs to be growing in a water environment. If there's no water, the willow dies. But the willow tree is very veinous. It has these tubular like straws, these veins that are designed to move the water out to the branch where the leaf is, because it's that water that has to collect the carbon from the leaf to create a rich sugar, and then the carbon moves through the body towards the roots, and in the path it's taken in by cell walls that are growing, using the sugar to swell the cell walls into growth. They harden and oxidize, a life cycle of any plant you can imagine. But every plant is different. Now, I don't know your species of trees, and I may confuse you if I speak about my own. I imagine we have some similar species families. But an oak tree out here is very hard wood. That means that the rings are very tight and they're very dense, and it's really hard to split, and it burns really hot but slow. And then a pine tree is very soft. It's going to decompose faster. It's going to rot. It's very big, fat grained, because we don't have old trees anymore because they cleared them all. So we only have thin ones that grow fast. They have big rings and they're really soft, and you can cut them open when they're green and they're literally pouring water out. They're so wet. The structure of those is different. You can see it in how you handle it. You can smell it when you mill it, and you can feel it when you build with it. Like, every wood is different, and I think you can rate your own trees to recognize them. The quality of that tree, of that wood, is going to be the quality of that char, because you aren't changing the cell structure, you're emptying it. When we burn, and I think, what size is it? This side of the screen. When you have this flame is the combustion of the sugar content. This side is the charcoal, which is the remains of the cell walls with no more sugar content. So there's still flame over here because the sugar hasn't finished burning off. But on this side, there's no more flame, and it's black. And in between, you can see it's red. It's red
Sure.
hot coal. So what I to simple summary of what I'm gonna get at, if you have any burn circumstance, a fire under any condition, in a container, out in the open, in a wood stove, in a cooking stove, it doesn't matter. If there's a burning circumstance of material, if you see flame, it is not done, because the flame is combusting the sugar content. The last color of the flame you will see is blue. You will see blue at the bottom of a lighter, at the bottom of a match. That blue flame is hydrogen. Hydrogen burns blue. Hydrogen is the last glue of the cell wall. So the last flame on a pile of coals is a light blue glimmering flame, because it's the final hydrogen burning off. When there is no more flame and there's no smoke, apply water, it becomes instantly black. As soon as it's black, you can pick it up and touch it. It is cool enough to handle. That is raw, barren of nutrients. There is no nutrients in there. Well, there's 5% nutrient and 95% carbon. Okay, so now here's where the percentage is going to get confusing a little bit to people. There was 25% of the plant was cell walls, right? And that cell wall carbon. That 25% of the plant was cell wall carbon. We are going to burn off the 75%. we are going to burn 75% of that biomass into the flame on my side here. And then we're going to narrow it down to, after we've burned off that sugar content, you're left with red hot coals that now, if they are allowed to stay red hot, they will become ash. What that means is, at 350 degrees and higher, carbon bonds with oxygen and makes carbon dioxide. So when you have a red hot coal and there's no flame, no smoke, the gray ash forming on it is the evidence of carbon emission to be carbon dioxide. Carbon dioxide is invisible and it's odorless, so you can't see it or smell it. And my business partner, Ken, just showed up. He's my enrichment guy. So he'll join our conversation here in a minute. But so essentially, when you do an above ground pile, you can get at best 10% charcoal, not the 25% that I said is available. There's 25% of the cell walls available, but the finished charcoal is 95% carbon and 5% the minerals that would have been ash, which be phosphorus, potassium. Those are also negative polarity, so they don't actually stick to the charcoal. They don't stick to the carbon, which is why they sit as a pile as super fine particles of potassium and phosphorus as your potash, and that is your ash at the end of a pile. That ash is water soluble. It will rain on it and it becomes a lye solution. Now we use lye to make soap, so when you mix lye water, a solution, an ash water is a lye solution, when you mix that with any oil, it creates soap. So by rinsing water over the coals, that lye solution of that residual ash is actually cleaning the rest of the charcoal out. So the lye will bond with any residual oils from the fire experiment. You know, if there was a smoke drifting, wafting down, the smoke can stick to the charcoal, adding oil to the charcoal. Now, charcoal that still came out of a red hot coal but still had the flame is behind me, if it was still flaming and you put it out with water, it still has volatile oils in it. If there's oils in it, oils resist water. If the charcoal can't take in water, it can't take in biology. So you need to have the charcoal able to receive water in order for it to be able to receive biology. That's where we get the word bio for biology in biochar, as in charcoal, because not all charcoal can be biochar, but all biochar is charcoal. Did that make sense? Are you keeping up so
Yes,
far? Am I
yes,
talking too
yes.
fast? Okay, great.
Yes.
So,
Ashua, you really bring me back to class in my secondary level in biology.
well,
It's
we
same
actually want you to
environment.
take this to schools. We want you to repeat this story to kids. I mean, if you want to organize a Zoom meeting where I'm helping give the lecture, that's fine, but you'll do better in person if you can learn this and share
No,
this. It's
this is going
inspiringly
to
simple.
it is going to the training of community members who come to train on our farm. It's
Great.
a pure training program for them, because this is too rich knowledge in
Yeah.
itself, number one, and number two, it is too rich additional components to produce food. We are
Yep.
discussing productivity now. We are going into food.
So the charcoal is, as we've just described how to make it, is barren in nutrient, right? It's hollow cells. Now, if this is charcoal made in a simple fire, we can get into a discussion about closed kiln biochar. We don't focus on it. And on your level, you don't need a closed kiln necessarily as a system. You can make small scale closed kiln systems that will work effective, and like a T-LUD, that's something to consider as a process. You can also, you'll find the fun of it is experiment with different methods and designs and how to make it at home, but don't get sucked into the online marketing for big, fancy, expensive machines because you don't need it. It's as simple as I said. Any fire circumstance, if the piece of wood is still smoking or flaming, it's not biochar, it's charcoal if you put it out. But what you'll see in the photo, the reason it's separated is I use a pitchfork. When I work in a fire, I used a pitchfork and I raked all of the incomplete pieces over to the flaming side. So everything flaming on my one side is the sticks that I moved from the other side. The cool air is cooling down the charcoal to be black. But because it's so hot, it's going to radiate. At 350 degrees, it's going to become carbon dioxide. So we need to bring the temperature down. This kiln is about 2.5, 3 feet, at least 3 feet of charcoal behind me in a 6 foot cylinder. Now, this is called a flame cap kiln. There's a lot of models. It's specifically called a ring of fire. You probably won't get officially a ring of fire there, so don't ever call it that because it's a patented name. She cannot patent the technology, which is a flame cap kiln. And what it means is the flame is the cap. There is no lid. As long as you have a flame as the cap of the kiln, flame consumes oxygen. So the bright white, in this case, it looks fairly yellow in the photo, but the brightest light of a fire or of a match or a candle, the bright white is the oxygen combustion, just as the blue is the hydrogen combustion. So when you have a bright white flame, you have a lot of oxygen there so that's why you blow on a fire to help it get going, is you're blowing in oxygen rich air to help get that bright flame that's going to consume the wood. So when you have a flame cap kiln, which could be just a barrel or a hole in the ground, the first book I told you I read, Terra Preta, they did not have metal. They had a earthen pit. I use my shovel as my measurement. The length of my shovel is the radius of my hole. So I use my handle and the shovel to decide where to unload it. I unload the shovel the equal distance from the center so that I make a circle by shoveling this in the center of the circle. And then when I get down to the height of the depth of my shovel, which is I guess 3 or 4 feet, then I've now come up above the ground 2 feet with soil. So I end up with a 5 foot cone shaped pit. And I dig all the way down to the bottom, and then I will shave it from my circle down to the corner. I'll shave it into a cone. And when I do that, I half fill the hole back up so that I then have to shovel it back out until I finally get it all empty. And then you have an earthen kiln. It is an earthen pit. What I want you to be very clear on, if you have a tree root there in that pit, don't use it because you can ignite a tree and then start an underground fire that spreads. The advantages of a pit: it's a fixed location in a farm where you're going to use it every year. You can leave it full of charcoal so you don't have a pit to be worried about falling in, and then empty it when you're ready to do it again. It's a place to store charcoal in that regard. You can pour your nutrients on it and shovel it out later. But you can also shovel and empty, use it again, and fill it up with charcoal again and continuously use it. And it's free by an hour's labor to dig the pit. Otherwise, 55-gallon drum, whether cut in half or whole. The key thing about what makes the flame cap kilns work is this has no bottom at all. Some kilns will have a bottom, like a 55-gallon drum could have a bottom. But the key is that we shovel dirt around the edges of the ring so that no air can go underneath inside the center of the kiln. Because if air can get underneath, oxygen gets underneath. If oxygen gets underneath, there's no longer a flame, it goes to ash. And if it goes to ash, you've lost your carbon. And the ash won't stay in your watershed. It's going to go end up in the ocean where it's not helping at all. But the minerals in ash, the potassium and the phosphorus, those minerals, and even probably some sulfur might still be in there, but those minerals are in the ash that are inside the cells of the charcoal. So you're keeping that bioavailable on your landscape, but it's like individual particles throughout the entire network. So it's not going to shake out. It has to be nutriently pulled out. It'll bond with other nutrients, and the mycelium will ultimately go in there, find it, and then pull it back out to the plants. So to get from charcoal to plant enrichment, that's the next step. If you pour raw char in your garden, you're going to run into issues because the charcoal is barren of nutrients, but is negative magnet polarity that basically says that it's the negative polarity means it'll pull nutrients out of your soil into the charcoal. So if you put it right into your soil raw, the first few years your gardens will suffer because the charcoal passively takes the nutrients with no competition, where the plant has to photosynthesis, energetically work up the magnetism to pull that nutrient, and it will lose the pace of the success of the charcoal. But in a few years, that charcoal will naturally homogenize, become enriched by the soil, and will be available nutrients to the plant. So to avoid the 2-year trauma, you put it in your compost. You put it in your chicken coop. You put it in your livestock night shelter or your barn or wherever they're peeing and pooping a lot, or at the water trough where they're making mud, or at the gateway where it's getting muddy in traffic. That's where you go put the charcoal, because then it can get enriched. And then when you scoop up that poop out of the barn area, you now are scooping up the charcoal. Now, when people talk about ratios, there's a lot of studies out there that are doing studies on small ratios, and that's fine. But in my opinion, aim high, because you're never going to get there anyways. But if you start with a small ratio, you're barely going to get to that even, and you're wasting your time. Go bigger if you're going to do it. You can go up to 50% charcoal in your compost, in your animal bedding. And the thing is that you can put it in straight as animal bedding, because their poop is going to be the other 50% of it, right? And then you're going to shovel that out. And this is based on archaeological research. The richest soil in South America that was made, that Terra Preta spoke about, was human-made charcoal mixed with human manure as well as animal manure, creating their soil, which is measured at 50% biochar. Now, the other soil I like to talk about, at least in our country, is Iowa. Iowa is the richest soil in our nation. Was, when we moved here, it was 18 inches, based on the writings that people did at the time that existed today, that we could look back and read. So 18 inches of the richest soil in the world was in Iowa. And we, unfortunately, in this nation have eroded it through tillage to only 6 inches are left. So in the 6 inches left that they've studied, the ratio is 50% biochar. Now, the biochar in Iowa was not made by pits in the ground with natives, which is what people in South America were doing. In Iowa, nobody was doing anything. And I'll describe the process. Grass grows out there. That's all it is. Rolling hills of green grass. The grass reaches seed, drops the seed to the ground. After it dries out, the seed falls to the ground. Now you have fields and fields of dry straw standing there. Nobody eats dry straw generally, so it stands there until lightning strikes some random spot, and now you have a spark. The spark ignites a grass fire. The wind blows the flame. Now you have a blaze covering huge pasture acreage, vast amounts of grass just burned up. But because of the distance between grass, the way it naturally grows, it competes for space, right? So the blades of grass, their stems come a certain distance from each other, but it's too far away to radiate the heat to ash. The winds literally cool it to grass charcoal in the air, and it lands on the ground, as now the hillscape is covered in black charcoal that is raw, but the seed is on the ground, and heat rises, and nothing was stopping the heat. So heat rose, and the seed is at the ground where it's cool, so the seed doesn't burn, and is now covered with charcoal, which means the birds aren't going to eat them all because the charcoal's burying some. And that's raw charcoal, so it's not actually a nutrient going to help the seed at all, but it won't matter because it's on the surface like a mulch layer. Now what it does is it attracts the sun. A black pile of charcoal on the ground also heats our ecosystem because it draws in heat. It becomes black and hot. But It warmed up the soil for the grass to sprout a little earlier. So now it gets a jump start on its spring because the soil's a little bit warmer because that black char draw the suns in. Now the grass grows over the charcoal, and all you see is a hillscape of green baby grass, which means it's cooler soil because the grass is shading that same charcoal. But now that charcoal is still essentially raw. But the grass doesn't care because its roots are growing down. They're not
Yeah.
growing in the char. It's the blades of grass that are covering the char. And what does a huge landscapes of green grass attract? In our case, it was millions of bison or buffalo, which unfortunately are my ancestors killed off and ashamed of. But what they did is they grazed that grass until there wasn't a blade left to eat. They competed with each other. This is where the rational grazing logic comes from. They all were competing for the same grass in the same area, and there were so many of them. They were pushing each other around, trampling anything that they didn't eat. Now, the trampling means that they've left carbon that is whole stem, stem of grass is now trampled in the ground, but also they've eaten that grass. And what comes next? They poop and they pee. Now that's when they start enriching that grass char. Because now they've left urine, which is sucked up immediately by the charcoal, and the poop, which sits as a patty, which then the wild birds come in, and the wild birds pick the patty apart because the patty's filled with maggots of flies that have laid their eggs in
Yes.
the patty. So now the birds peck apart the patty, so now the manure spreads so the grass can come through the patty. So now the grass grows back after the bison migrate because there's nothing left to eat. So the bison won't be back in time before the seed gets made by the grass, drops it down. The buffalo come back through. There's nothing but dead straw. So they keep going looking for green grass. Lightning strikes, cycle repeats.
Yeah.
Millennia of that behavior manifested the richest soil in the world in Iowa, nature made, and it's
Nature made, yeah.
50% carbon up to 18 inches in the soil. Okay. So I'm not expecting you to add 9 inches of charcoal onto your garden bed. But what I'm saying is, if you have a foot deep of compost, you can add a foot deep of biochar, and now you have 2 feet of compost char mix. Now, when you are spreading that across your landscape, just as you would in any learned garden practice behavior, if you're mulching with compost, now you're mulching with compost enriched biochar. So you're adding equal parts char as you are adding compost because the compost is being absorbed into the char because it was porous, barren sponge nutrient absorbing. It holds nutrients, it contains none. That's a misnomer. People think the biochar is a nutrient. It is not. It is able to hold and store water and nutrient just as nature intended it when it grew the cell. The cell was there holding nature's water and nutrient, and every tree has a different aroma. But the charcoal has the same aroma because you've removed its individual sap and sugar, but now you're enriching it with your garden and your soil. So the simplest way is to get it in your compost methodology, to get it into your normal garden beds. But if you're doing tree planting, get that in the hole. Get some charcoal in the bottom of that hole that you're planting a tree. And if you're doing a seedling, dig up a space to put some charcoal mixed in so the charcoal will be found underneath that tree. But otherwise, you can stick pretty much topical. Earthworms will bring it down, gophers will bring dirt up. It will get mixed in through nature. Like the Iowa fields, nobody was enriching it. It became enriched as it went down into the ground. But if you're doing a process, you can be incorporating it. Now, what can you make it with? anything. Your grapevines, highly recommended. Those will be supple, and if you can actually cut your nice straight pieces and get a paint can or something and collect up your pieces, puncture a little hole in it so it lets the steam out, and then put all your straight pieces of grapevine in there or willow and put them in a canister, close the canister, stick it in a fire. Now, you're going to have, if you had a hole in it, you're going to have that steam coming out. That steam is the sugar content. And if it's in a fire, it's going to be a little blowtorch. You're going to have this torch of flame coming out. When there's no more flame coming out of that container or your fire's all done, because you had a lid, you stopped the oxygen from easy access to get in, which means you've stopped it from going to ash. Now you have a container full of charcoal sticks, which are sold for artists, charcoal. You can take that to your schools for children to draw with. You've made your own charcoal. And that's a great use for biochar, is using it as a drawing tool to inspire creativity, to draw the vision of your next plan, your next construction, your next home, your next garden plot plan. Like, charcoal is a valuable material for art, and you can make it out of what's traditionally done is grapevines and willow. And that could become a product that you even sell internationally, as this is whatever you can go that route, but ultimately charcoal is going to be good for your soil. And so all those grapevines are going to burn up really easily and really simply and fast. And so this is where I would recommend burning similar stock. So when you're doing your grapevines, burn your grapevines. If you're going to do trees that you're thinning or opening a pasture and it's a big tree, I would wait till the tree is either dead or dried out. They do make moisture meters, and they recommend 20% moisture content or less. I don't expect you to need a moisture meter. If it's wet wood, you'll know it's hard to ignite, but it ultimately will not matter. Whether it's green wood, dry wood, or wet wood, it'll be how easy is it to burn. The wetter it is, the more likely it's going to bellow smoke, the harder it is to get to ignition. But if you're a good operator and you have a kiln, which is a flame cap kiln, an earthen pit kiln, those are kilns. If you have a kiln, you generally have a higher heat temperature. So to try to explain a few variables, we have 25% of the plant available as charcoal carbon cell wall. The only way you're going to get 25% out at the end is if you have a closed kiln system where you completely control the input of air and you don't allow oxygen in, but only nitrogen or something. And you try to control the air and you can get 25% out. The reason no industry is doing that is because all closed kilns are so expensive to make that they are funded by the interests of the power that machine can generate. So they want to make money off selling power, and the biochar is a byproduct. That's cogen. The quality of that char can be questionable for a few reasons. Some systems, they burn at a lower temperature. The lower temperature charcoal ends up with higher sugar content left behind, which means volatile oils left behind, which means it could recombust later, which means it sounds less stable to me. When you're burning an open fire, like I have in the background, it's up to 1200 degrees. That's a pretty hot fire. But the charcoal below is like 400 degrees. But the heat is up top, and that's what's releasing all of those gases. The high heat keeps the flame strong. The flame is consuming the smoke. Smoke is cool. It's not hot enough to be in flame, but it's just the sugar contents leaving as steam and smoke. But if you have a high enough heat and a flame, the flame will consume that smoke, and then you'll have a bigger, brighter flame. Now, in an open pile, the air blows from the side, whatever direction. You're in an oxygen-rich environment. The fire heat leaves the combustion site, the pile, in a sphere. It goes in all directions. It goes down in the ground, it goes across the hill, it goes up into the sky in a sphere, but also rises up. So maybe it's almost conal. But if you were underneath trees, you will see heat scars from an open pile, a significant distance around the pile. You'll have trees that have burned up and dried off. Leaves will be dying a week later or days later, even that evening. You'll just see that it's dead leaves because the heat of a flame combusts out and it's going to burn off trees. When you have a kiln, you are closing off all the air from the side. The only air that enters is from the top, the lid, specifically the flame cap kiln. The only way air comes in is over the top. And because of that, the air can't come from the side. And the air that comes from the side cools down the fire. When it cools down the fire, it will make ash at the bottom of the pile while the sticks at the top are still burning. But with the kiln, the oxygen can't come from the side, which means the charcoal just sits there red hot waiting for oxygen. But as long as you have wood burning on the top, you have flame combustion, the flame consumes oxygen, which means the charcoal is going to build up underneath. Now, we use pitchforks and metal shovels. I burned quite a few handles as a result of this. So learn to make handles. Those are great to repair shovels. But you basically you use the pitchfork to dig into the pile. A shovel can lift up charcoal. A pitchfork cannot. A pitchfork can lift up wood, incomplete burn, because it's a stick still. It's still holding structure. The pitchfork can sift that out, where a shovel was going to remove charcoal too. Now, if you're doing a wood stove in a house, if you just let that burn to ash, the ash builds up and you end up having to shovel the ash out. That's the process. But if instead, when the flame is done, instead of simply adding more wood, you shovel out a majority of the coals directly into a bucket of water, you now have charcoal. And you leave some of the coals and you sacrifice it to ash so you don't have to start over again on building a fire. And now you add more wood to those coals. Now you get your fire going in your stove. You're going to have less ash build up in the stove if you keep removing the charcoal. But if it's flaming, smoking, put it back in. It's not done. Now, in an above ground pile where you have no kiln, you just have a pile of brush. This could be prunings from your orchard. I would do orchard prunings together. Probably you could do the mix with the grapevine, but I would probably, if you have a tremendous amount of either, I would just do them separate, because the grapevine will burn unified, consistently temperature together, and the trees of any type of tree is going to burn pretty similarly in an orchard. Same size type of wood, the diameter dimension. If you want to do bigger trees, if you have like dead tall pines like we end up having out here, dead pines and firs, you can actually split the wood. Splitting it down.
Yeah, we have wood stove. We have trees. Yeah. The types of trees we have comprise of the natural traditional trees which were there by nature. Yeah. We have around the farm, and since 2016, I personally have advocated for leaving those trees intact.
Absolutely, they are most active.
Because yes, I advocated for that because not only trees provide windbreak, but these trees, some of these trees, the natural trees, in my own research, I got they were natural fertilizers. Because my grandparents, my father used to say that they have scientific names. There are some trees which, when you plant sorghum under them, you plant beans under them, and you plant sweet potatoes under them.
Yeah.
The yield was so much, other than when you clear these trees and
companion planting and using the trees. Yeah. Yes. They help build the soil for the tree. They're working together.
So these trees, when we prune them, we have lots of branches falling down, and sincerely, great. I have
Those
another
are perfect
advocate.
For biochar.
Yes, I'm going to advocate now not to use these branches of trees, because some members would collect and go to use for firewood, and some members were making charcoal to cook out of these branches of trees. So I have a reason to speak now that we are going to use. We are going to use these branches for biochar
Right.
to aid our soil nutrients in
Right.
so
And
many
there's some
ways.
good videos out there and how you can there's some I don't know, I think it was in Kenya that I saw these videos where they were using three sticks under a pot to burn, and that the sticks would be like three matchsticks, but they were like wood sticks. And by keep scooting them in, they keep the flame going in the center, and then they could rake out the charcoal as it was developing, and then you have a steady flame to cook with. You still end up making charcoal because we're still a fan of cooking with fire. So I'm not an advocate to stop that behavior, but to learn the people to train the people that are cooking with
Yes,
fire
to
to
make
make
use, yeah.
charcoal at the same time, to end up with, if
Mm,
they can understand the benefit. As an example, also to know of a statistic, a 5 gallon bucket, I imagine you have those 5 gallon buckets, they are
mm,
about 5 pounds of carbon when it's full of charcoal. That's equivalent to the emission of carbon from 1 gallon of gasoline.
The benefits of biochar
Yeah.
uh, against cooking, I see the benefits lies much in making biochar,
Hmm.
and and is better than cooking, even according to me.
Yeah, yeah. I mean, you got to
So
cook somehow, though. So I'd rather them cook
yes,
over wood than some propane.
I will explain this, and I'm sure all my members listen to me. I will change that mindset so that we bring this biochar use into practice. And you see, once the community looks at this benefit, when they come on our farm, automatically they are going to adopt to that,
Right.
and it gives it will give more benefit. It will give more benefit because it is the nearest way to improve our soil
And is
nutrients.
your soil a bit more clay or sand?
Yes, and this is more organic than running for artificial fertilizers, etc. So
Absolutely.
I'm in a real program for this now.
Is your natural soil, is it a bit more sand or more clay?
Our soil is our farm comprised of loam
Loam.
much and sand much. Clay
Okay.
is less. Clay is always got around the ant hills.
Okay.
Otherwise, we have loam and sand.
So the advantage of the charcoal and sand, because they're beneficial to both types of all types of soil, but in different ways. In a clay soil, they're going to add air where air isn't because it's the air inside the charcoal. But in the case of sand soils, water flows through sand quickly. It doesn't stay
Yes, yes,
easily. Where
yes,
charcoal
sure.
is going to suck up that water and hold it right there. And the charcoal isn't living, so it has no intention or purpose. The landscape will decide what to do with the water by sucking
Sure.
it. The charcoal
Yeah.
will let it go, but it'll hold on, and they use charcoal to filter water because of the fact that everything will stick to it. So like the heavy metals and toxins that are in the land or in the water, if there's charcoal in that land or in that water flow, the toxins, the heavy metals, the antibiotics, the pesticides, all these things, the pharmaceuticals, they'll get sucked into the charcoal and stay there because the plants don't need it. And if they don't need it, they aren't asking for it through a magnetic pull from the mycelium either. So that's where it can become a remediation. And when I was describing earlier using hemp to grow over a soil that's been polluted that needs to be remediated, you can suck it up in the hemp, convert that hemp into charcoal, and now you've locked up those elements in the charcoal. And they literally make roads out of charcoal. They mix in a closed kiln system or even in a hood with a pipe that you could capture some of the smoke that you do generate and recondense it as a tar. You mix the tar with the char and you've made asphalt. That's like what asphalt is. And so you could do repair of road work with any questionable wood that you're not sure you want to mix into your ground. Like if you're, painted wood or pressure treated wood or something that's being, available to burn, but you don't necessarily want in your food garden, or you're nervous about it, you can use it in a road area. You can use it to fill potholes, mud holes, because it's more structural than a wood chip and it doesn't decompose. The carbon of biochar is crystallized by the heat of the fire, so it can no longer decompose or evaporate into carbon dioxide unless it's over 350 degrees, which is hard to do if it's in the soil and full of nutrient and water. And so to get the enrichment, so if you put it in your compost program, you could put it at the bottom of the compost pile, and any water that flows through your compost that leaches out, it will filter and absorb the nutrient that would leach out underneath the compost. If you put it over the top of the pile, it will absorb the gases that escape from the compost, except carbon dioxide. It won't apparently absorb that, but it will absorb methane and sulfur dioxide and all the reasons you don't compost inside, because of the gases that they emit from the compost. And those gases in a natural environment would be absorbed by the plant life over that composting, decomposing matter at the soil base. I'm kind of a leave it and let it compost where it is kind of guy, which is where I would just spread my charcoal over the surface of my soil like a mulch. But enriching it before you spread it is the quickest way to get it to where you want it to be. So what we would do is we'll use in the compost, to continue that thought. So putting it over the top of the compost will reduce emissions of your compost, because charcoal absorbs gases before it absorbs liquids. So it absorbs both, but the gases goes through first and then the liquids go through, and then charcoal has a finite capacity. It can only store so much. A significant amount, but it's still limited, which is why this should be an ongoing process. That every year you're making charcoal multiple times a year and incorporating it in multiple processes. So I mentioned peeing on it as a great nitrogen into it, but I also mentioned buffalo pooping on it. So in the Terra Preta book, what they did in South America is they had shit pots in the house, ceramic pottery that was used to shit human feces into, and then they would put charcoal on top of the poop some more, charcoal on top of the poop some more, then your bucket gets full. When their ceramic pot began to leak, they would chuck it into the pit. And that's why they have terra preta, is there's ceramic shards in these pits. And they didn't understand why until they reverse engineered the archaeology to deduce they were human shit pots, and that they were mixing their human shit, because that's all of our nutrients that we're letting out. We consume all these nutrients. Our manure is our fertility. So I now poop in a bucket, a 5-gallon bucket, and every time I poop, I cover it with biochar. I put a little bit at the bottom at the very beginning. And then as I get the bucket full, I put a lid on it. And these are recommendations that came out of that book, Terra Preta. You put a lid on it for 3 months. Now, I don't know if she's legally obligated to say that because she's trying to be safe, or if it's a legit necessity. The reason and argument in the book for 3 months with a lid on, it's an anaerobic environment. That container is going to be filled with anaerobic bacteria trying to conquer that manure, right? The charcoal's not doing anything. It's only the manure that's attracting the bacteria. What's key to understand is don't pee in your poo bucket. We pee on, men and women both pee on opposite sides of the body as you poop. You pee out the front, you poop out the back. Every animal does this, because when you mix urine with manure, that is what creates pathogens. So it's safe to pee in your charcoal and it's safe to poo in your charcoal, but don't pee and poo in the same bucket.
Yeah. I can see I visited one district where our farm is located in northern Uganda. Some Netherlands NGO brought a kind of latrine, a latrine where they have built it in such a way that it has two containers. The pee goes into the jerrycan container with the lid. and then the feces goes separate. And they were using this in a in that latrine after easing oneself, the feces, you pour ash. You don't put paper and other
Well,
things
go
there.
reach out to those people, visit them again, and convince them to put
They
charcoal instead of ash.
they have gone back. It was a 3-year program, and it was closed from Netherlands.
Yeah.
But in the district, no one, not single person, continue with that arrangement. But in the 3 years, so many people celebrated the the yields of banana. It was mainly used in the production of banana plantains. So you find
Okay.
if when the pea is collected and it has taken one, they go and put it under the plantain. And then the feces decay also with the ash. For them, it was ash. And in this case, it should be biochar.
Absolutely.
Then,
It'll be
and
so
then
much more beneficial.
yes, bunches of banana were so many kilograms for each bunch. And it made all the members of that Netherlands organization, I think, uh, rich. They were able to oversell their bunch of bananas and they got money in 3 years. Instead of coping and continuing up with these programs, these people left the arrangements. And this Netherlands organization built free latrines and provided free containers. I personally used the latrines when I went, where you defecate separately and urinate separately. And this brings back it brings back to me that I can use our latrine. I am going to use our latrine as a demonstration
I've actually
program.
I've seen a design that was they use a 55-gallon like plastic food drums to poop in, and then they
Mm.
made a latrine that was a staircase that you went to
Yes,
the so that it's above
exactly.
that barrel so you could change the barrel out. And I've heard of a story in India where they to get the nutrients for their local community, they would try to make the most beautiful latrine as they could so that the tourists would use their toilet because that was more fertility they were getting the tourists to leave behind. And so the tourists would use the prettiest, comfortable toilet. So they were aiming for trying to make a really beautiful toilet experience because they valued the nutrient collection that was happening in those facilities. So if it's
Check.
not a comfortable place to go, who wants to go?
You see, this is an eye opener for me because personally at home, I am using my latrine and it is getting full soon. This is where I'm going to empty it and put with biochar and decompose to use.
It
I would
it
have
it
wasted.
doesn't smell anymore when you cover it with charcoal. Like the aroma gets absorbed by the charcoal. Our
This
poop,
is
our
good news.
livestock poop, all of it. Like a chicken coop is toxic to go into. You put the charcoal on the floor of the chicken coop, it instantly is less toxic to go into. You'll immediately notice the difference in smell. Now, of course, when it talks to any animals, including chickens, I'm going to do the rational grazing practice, which is moving them every day. And if there's nowhere to move them, then I'm holding them somewhere I want to build up my fertility and then bringing them more to eat. And the spacing on that is really about size. A small herd is fine. You could do the same behavior. You need a pen the size that they can socially get along and not push each other into the pen. I use electric wire to contain all my animals, and that way I can move the wire in 10 minutes a day, and I give them new space and I take them off of old space, so they're never on the same space for more than 2 days. The first day is when they get the best value. The second day is me just trying to reduce my workload and give more manure buildup on that site because I've left them there. And with the 2 day system, you can add a day and take a day and have a day in between that's lingering. So every day they get one fresh portion, one old portion, and a removal of an even older portion that was 3 days ago. And so by doing that, you're giving the landscape more opportunity to regrow so that there's
Yes,
more
yes.
food. And the term, and I got this from the book Grass Productivity, which is the basis of Alan Savory's book in Holistic Resource Management. And it's called rational grazing because it is a ration of food, one
Mm,
day's serving. They should have
mm,
enough one ration to eat. They should be able to eat all of it. If the pen is too big, then there's still food left over that you leave
mm,
them there second day anyways. But if they haven't finished eating it in 2 days, you could have made a smaller pen. Now, if you
mm,
make too small of a pen and they push each other out, that's how you'll know it's too small of a pen because of the
mm,
social order. You have to, with
mm,
cattle especially, you have to accommodate their size for what's an accessible size of pen. One of the ways he describes it is you have 5 hooves, the one of each foot, and then the shit that they drop and the mouth that they ate.
mm,
You know, they're not going to eat where they shit. They're not going to eat what they trampled in the ground. So for one mouth, they're going to have 5 others that are destroying their own food. So if you're
mm,
moving them slowly, they will eat what they can in a competitive form. So they eat all of it, hopefully before they shit on it. And then they're just laying there now shitting on it because they got nowhere to go. So they're trampling whatever's left behind. So it's a more efficient effect to the landscape. You get the grazing down better, but you get a better manure distribution.
mm,
And
mm,
now when it comes to charcoal, so there's discussion about feeding charcoal to livestock. I have
mm,
no objection to allowing them free access to it. I've given them all free access to it. I have mixed it in salt. I have mixed it with molasses to try to encourage them to eat it. I did not find success with that. I found them using, I have horned animals, and they would flip my container over, and I would have to make a new container they couldn't flip, which then got heavy to try to move on a daily movement. So I
mm,
abandoned feeding charcoal. And the reason I really abandoned it is because of the study that I read where they said that the livestock that are eating the charcoal are wearing down their teeth prematurely, which means their teeth is the basis of how they get food from chewing vegetation.
yes,
If they don't have
yes.
good teeth, you don't have a long, healthy life. So this is where I segregated from, okay, the difference of these studies. All livestock, unfortunately, in America, as far as I can tell, is focused on beef and meat. They just want meat. Okay, I'm not focused on meat. Meat's a byproduct. I eat meat. I'm not a vegetarian, but I do enjoy vegetarian dishes. I'm an
Mm,
omnivore, but I do dairy. Dairy is more interesting to me. I like yogurt. I like ice cream. I like cheese.
sure,
I
sure,
like
sure.
milk. So I have
I
dairy
too.
cows, which means I'm keeping that lady for a long life because I can't
Mm,
afford to replace her like the commercial dairies do. I'm keeping that old lady till she's retired, which
sure,
means
sure.
I need her teeth to last her whole
Mm, mm,
life. Okay. But the
yeah.
studies were done by beef industry where they're going to butcher those animals in 6 months to a year or two anyways. So who
Mm,
cares if their teeth are wearing down? They were getting benefits because when you now it is safe to ingest eating charcoal. It is not
mm,
safe to inhale or breathe charcoal
mm,
dust.
mm,
The
mm,
most dangerous part of charcoal is the black dust. Mists of water capture it and drop it to the ground. The particles of it is solid carbon. If you inhale it, it'll stick to your lung like it sticks to anything else. That's what kills miners. It's
mm,
called
mm,
black lungs disease. Very difficult to
mm,
remove. If you've gotten exposed to a lot of it, I'd look into lung healing herbs like mullein and making mullein tea or maybe even smoking the mullein to try to remove and expel anything in your lungs. So the true method is avoid inhaling any dust of making it. When you quench it, often if you use too much pressure of water, you'll cause a cloud of black soot to come, or not soot, it's char, black charcoal flour to bounce out with the high pressure water. If you use a
That's good.
misted low pressure water, you'll capture all of that. Now, even
Good
when you're not
information.
making it, but if you have a bucket of charcoal, or you're even at your toilet, you have a bucket right there of char and you're putting a handful on top of your poop. If that charcoal is too dry, it will be airborne. If it's airborne, you can inhale it. So a bit of moisture is good for the char because it gives it weight. If it's saturated with water, I probably wouldn't put that on my poop because I want it to absorb the aroma of the poop. So you want it to be a somewhat dry char for that benefit because it'll take in the nutrients. To go
Good.
back again
Thanks.
about the 3 months. So in Terra Preta, she says to put a lid on your full poop bucket for 3 months to allow the anaerobic bacteria to conquer everything in there. So the entire feces is coated with anaerobic bacteria. Now you apply that as a layer in your aerobic compost. The aerobic bacteria will consume the anaerobic bacteria. So you are speeding up, you are hastening the next evolution by homogenizing the anaerobic bacteria to make the manure now anaerobic bacteria because the bacteria is consuming the manure. So now the anaerobic bacteria is the food for the aerobic bacteria, which is the air loving bacteria. So using the 3 month aged manure and then mixing it into your compost, which could age another 3 months. So now the aerobic bacteria convert the anaerobic bacteria, and you're hastening and you're avoiding pathogens because you're peeing on different charcoal and layering that as a different layer. And that's my memory of the basis of the argument for why 3 months to store it to allow the anaerobic bacteria to conquer it. Now, I like to eat brie cheese, which is a white molded cheese. So my bucket of char, when I open it up after even just a couple weeks or a month, it's growing a blooming white cloud of mycelium, which is the Penicillium candidum, which is the mycelium that grows on the white brie cheese, the white molded brie cheese. So I expedite the mycelium with my choice in diet to eat a mold food. But you can also cultivate your native mycelium in your mulch in your compost pile. And you can use that and mix it, when you're doing your poop bucket, you can mix a little bit of that mycelium enriched leaf litter as well as your char to just throw in inoculation of mycelium in there. It isn't necessary because mycelium's in the air. It's all over. We're inhaling mycelium, all the spores all the time. So by just having a nutrient rich food source, mycelium and bacteria will land on it. So the first the first life is bacteria. That's the smallest life. The bacteria is eating nutrients. So when we go back to the plant, and what's burning is the sugar content inside of cells is the sugar. That's what the bacteria is wanting to eat, is that sugar. So when you have raw empty charcoal and you want to get mycelium into it, you first have to get bacteria into it. And in order to get bacteria into it, you need to have nutrients into it. So that's where what we do is you can do a compost tea if you do any type of compost tea methods, soaking manure in a bucket of water and make it a slurry. If now it's a poop and water, that is a nutrient rich brew. And so when you soak your charcoal in that, you're providing it with all the nutrients in there. If there's nutrients in there, that's what's going to draw mycelium in there. If mycelium's in there, now you have a vein that connects the inside of the charcoal to the outside of the charcoal. And that vein of mycelium is what connects to the living plants, which is how the charcoal is becoming a battery storage bank for plants. Because the mycelium is the vein that connects the nutrients within the charcoal to the plant which is needing them. But the mycelium can also bring nutrients into the charcoal to put it in there for storage for later as part
Mm-hmm.
of the
Now,
siphoning up of water, and because most nutrients are in the water that's leaching off of from rains, right? And
yes,
so
yes.
by
Question.
having charcoal anywhere on the landscape, you're avoiding that question.
Okay.
Yeah.
Yeah.
Do you have a question?
Uh, in this case, sure, when we are going to use branches of trees, some some volume of the charcoal will be big. In that case, do I need
Mm-hmm.
to crush it, or I leave them as they are?
Right.
Because yeah, do I need to crush them
Okay.
into small
It
portions,
depends.
or
This depends, and there's variables. For one thing, you again, the size of the wood you put in is the size of the char you get out. You put in hardwood, you're going to
yes,
get a hard char that's larger.
yes,
You put in softwood, you get
yes,
soft char. Grapevine is going to crumble, really soft and simple. So every material is different. So if you're going to do a hardwood, like I use oak,
you,
if for in our case,
we have hardwood. We have
right.
some
So a
species of
hardwood
trees.
charcoal to try to make
Mm,
that into a fine flour of black char is a lot more work. It's a lot more
yes,
difficult. So
yes,
I
yes.
don't do it. I don't bother. I use it somewhere that it won't matter the consistency that it is. So we will
Okay.
fill wattles, which are just fabric tubes, and we can use that for erosion management, for controlling water flow, for filtering a stream. And so we can use the
But
wattle as a means to carry it there and to lay it across the landscape on a swale line or on a key line.
yeah.
And that material is going to break down, and the charcoal is going to distribute on its own from there. And that's a case where I'm using it as a landscape management, not as a garden bed I'm trying to enrich, right? And
Mm,
so a lot of times where we're working is we're working in forests where erosion is serious because the trees are gone, they've been burning off, and now
mm,
there's just the loggers are taking trees with tractors, and so there's just all this exposed clay, and it's just going to erode. So by making water bars and using these wattles of charcoal, we're going to capture some of this erosion and settlement. So in those cases, a nice hard wood charcoal is going to be great
mm.
because it's giving structure, almost like a rock. It's giving some
Good.
support. It's going to build up some soil. Now, when you're going to
But
go into your garden bed where you got your carrots
mm,
and you got your
mm,
turnips and you got
mm,
these sweet potatoes and you want it to be supple soil, you're not going to want to put your chunky hardwood charcoal there because the plant's
mm,
going to
mm,
a funny carrot is going to grow
mm.
around that
Yes,
shape.
yes,
Okay, so
yes.
this is where you can use a screen to
Mm,
sift it, and just shovel it onto a screen. Whatever falls through the
mm.
screen is nice and sifted. Go ahead and use
Good.
that sifted charcoal into your garden bed, and I'm sure. And if you have a driveway with vehicles traffic, you can
No,
put it in
I
the
don't
drive.
have.
No
Which
vehicles.
I'll use hammer. I'll
Just
use hammer.
hammer. Okay, so
I'll use the hammer.
um,
Heavy hammers.
heavy hammers to crush it. So I've done mortar
Yeah.
and pestle. I like hand mortar and pestled
Mm,
charcoal, and I found it was tedious. So the way I look at the different, so having different sizes, like for the case you're going to use a fruit tree pruning, there's going to be
mm,
from 3 to 4 inch branch all the way down
mm.
to the eighth of an inch tip of the branch, right? So this tip of
I'll,
the branches, you can sift it from the screen and easily have all the thin charcoal as smaller charcoal, and then use your
I'll
bigger
keep.
stuff somewhere else. But you can also, what I find is you can crush it with your hands to decide how hard is it to crush. But the way I
Mm,
look at it is when you crush it and expose it, I mean, it can only break down physically, not decomposing. Like an earthworm can eat it, but it won't break it, it won't decompose it. It'll just make it to smaller pieces that it chewed,
mm,
and then it's enriched with their manure when they poop it back out. But if you put it in the ground, it's like a al dente noodle. Like the center of it's not done. The edges of the charcoal are coated in nutrients and benefits, but the center of that charcoal it's going to take a while for the nutrients to suck into the core
Yes.
of it, right? But
Yes. Yes.
if in the process of your harvesting and you're tilling, or not, I'm not a tiller fan, but you're tilling it by pulling your potatoes out, right? The soil's
Mm.
aggregating as you're moving stuff. It's going to break down later when you walk over it
Okay.
in the path.
Mm.
It'll crush later.
Mm.
So the
Mm.
way I look at that is that center of the charcoal that wasn't enriched is now exposed because it was in the future, unknown next year or 20 years from now. In the
Mm.
future, it's going to get crushed or broken open. And
Yes.
in the act
Yes.
of it, now it's exposing fresh charcoal to
Yeah.
capture new and fresh nutrients. So it has a long-term advantage in that regard to have mixed sizes. Because if you
Yeah.
get it to be fine as a flour, it could also flow away with your water if you have a heavy
Yes. It
water tank.
escapes. It
So
escapes.
there is a value for having different grades of charcoal, and I don't think it's necessary to get neurotic about hammer crushing it to a fine consistency. But you might find a situation where you want that in your garden bed or a specific bed. And again, use a screen and sift it. Don't try to make it all uniformly fine
Mm.
unless it's
Mm.
something you have a use case that you need it to
Mm.
be that fine. Does that make sense?
Fact. Fact. That
Yeah,
is
because
fact.
if the mycelium goes into it and then it swells, it in itself could crack the charcoal open. A
Mm.
root could
Mm.
crack it open. So the
Yes.
charcoal
Even
will break down over
plowing.
time. And
Yes.
putting it in a
Even plowing.
traffic zone, if you have a big chunky char, put it in your cow traffic zone. I don't really know the routine of your livestock, but often there's traveling over the same terrain. So you can use the weight of your livestock to do the crushing, so they could crush the
Yes.
charcoal and then scoop it back up off the ground with whatever other dirt, clay, and or sand and whatever other enrichments the animals left behind.
Yes. Even like we have two seasons. When in the season of April, we have used the nutrients applied to the soil.
Mhm.
When we are plowing for the second season of August, even the hand hose can break the charcoal and
Right.
open new
In the process of
surfaces.
just moving to
Yes,
working your ground.
yes,
Right.
yes.
And so that's where
Oh,
I like to keep everything simple, because the more we make, the greater the benefit. So when you start getting experience because you're making it and using it, you'll come across that garden bed that you're like, oh, that hardwood, we really should have crushed it because this is a good bed. And then you'll know that. And next time you'll go, okay, why did I bother crushing it? Because this garden bed, I didn't do it and it did just fine. So you got to gain experience. But the risk you have of hammering it by hand is the center of that charcoal is probably dry. You're going to expose the dusts. So whoever's doing it needs to be wearing a mask. But it's not even,
sure.
and
That is true.
having water
True,
nearby that you could mist it
true.
even with a small pressure mist, or to the a thin moisture can capture it, just gives it enough weight to bring it down. So to be
More
clear,
safe.
the
It's more
charcoal
safe.
flour, which is
Mm.
just solid carbon molecules that are light enough to float in the air, they stay in the air range of our breathing environment. So it's not just you, the worker. As it drifts off your farm, it is in the breathing environment of all of your neighborhood for up to 7 days before
Oh,
gravity could drag it into the ground, or it hits a moist leaf or dewdrop, which sticks it to the soil. So the more that you can maintain keeping it from becoming an airborne black cloud, the better for everybody's sake. But
I
ultimately,
believe.
it won't go back into the atmosphere and create carbon dioxide. It can't do that. It will still fall as a piece of raw char on the ground somewhere, but it can be inhaled in that week. And that's just want to be very clear. That's the biggest and only risk that I know of biochar. Otherwise, everything else is pros and benefits. So, but yeah, I mean, enrichment methodology can go many different directions. What we like to do is create a bacteria rich liquid solution that will soak into the charcoal. So then the bacteria is attracting the mycelium because the mycelium feeds off bacteria.
This is true. I wish we met. We met 3 years or 5 years back. I would
Well,
have
I
got
probably didn't know it
all
all
benefits.
5 years back.
All benefits would have been in my hand.
Yeah.
And
Well, you're learning now, and I appreciate you reaching out so that you could learn. And I'm happy to continue this conversation with you other days as well. If you get questions or if you want to develop an audience for your farm members to come and share the
yes,
questions, I'm very willing to repeat this experience. I repeat this story hundreds of times a month because I just love
I'm
to
so,
inspire people about how simple it is.
I
And
don't know how much I can thank you for your time.
mhm,
This is not a small thing into practice. And
mhm.
this is going to be the life of Mamo Gardens, because when I will hand over from the directorship of the garden, I would like to leave this a written material which cannot stop. You have planted a seed which is going to germinate for Mamo Gardens, the whole life of the garden. And I'm very happy to continue with these conversations. And no wonder it will include us. We are going to be members, because I will make I have two volunteers, one in agroforestry and one in crop foods, that is agriculture. I will bring those volunteers into the Zoom meeting, and we share and we put into practice. Nothing is going to be left outside the farming process. Everything you have mentioned is going into our soil.
Right.
Because I was thinking of making soil tests to know what we have in these 20 acres, but it needs funding. The
Yeah.
soil test is done only at Makerere University, and there are fees attached to each
Yeah.
test.
So, I mean,
We
I've
as
been to many workshops where they showed us simple tests you can do yourself for no charge to find out your own quality. One of the things they did is they put a cylinder on the ground with a measured volume of water, and then they pour it in there and they time it. And they go, how long did it take the water? How long did the water sit on the soil? How long did it take to penetrate? How much could I pour in before it puddled? And then they did this every year to see
kindly,
how did it change, because it isn't so,
kindly this.
because then you can see when you're doing the additions, and you can see how did what you do in this plot or that plot change if you're doing testing.
Kindly, that is the knowledge we need. We
Yeah,
are truly hungry for knowledge at
I
Mamo
believe it.
Gardens. It is a challenge for me at the headship that I bring all down, because everything will be seen from what I've done as the director. I'm so happy I have a reason to celebrate 2026 with an achievement to meet you. I'm
I
very,
am
very
really
happy.
grateful you reached out because
And,
you are the first person in Africa that I have spoken to in a Zoom conversation at all. But you're
um,
the only person who's the other ones I get from Nigeria. They're always asking me for money. And you're the first one that's like, I just want your knowledge. We have resources, but I want your knowledge. And I really appreciate that you were very
knowledge.
articulate with me, that it was something I could give you. I could share what I know. And I can share more than we'll have the energy for in this phone call, but I'm happy
Sure,
to have
sure.
more conversations. But the basis of biochar is make it, get it made, get it enriched and in your soil. But there's no real rule. It's anything will work, and you'll learn to experience with what you have. Do you have you are you familiar with the Polonia tree?
There?
A Polonia. Have you heard of a Polonia tree?
No.
There's a
If
tree
you,
called the Polonia, or the Empress tree. It's the fastest growing shade tree in the world. But
maybe I am forgetting, maybe I cannot compare the tree with the name. If you write it
it's
down for me,
true.
I can,
Um,
it could be
yeah,
biological name.
I'll type it in this chat. Let's see here. The elephant tree.
Yes. You know, uh, knowledge is the wealth, and our wealth lies in what we are producing. You may give me money now, but that money cannot buy this very knowledge we are talking about at the moment. And then when we talk about biochar and natural nutrients of 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 manure, these are things I have for free. I'm not
Yeah,
going to buy branches of tree.
right.
I'm not
The
going
reason I
to
bring up
pay.
this Polonia tree, which I typed it in the chat, the three trees are the same tree, is
Yes.
Polonia or Empress tree or elephant tree. There's varieties. This tree is the fastest growing perennial tree in the world. And we use it to plant to create shade, but also to create biomass with which to make into biochar. The tree can get 60 foot tall in a few years and become a hardwood millable timber that you could use for the lumber besides making the char. But the thing that's really great about it is the leaves. The reason they've evolved to grow so well is that the leaves have every amino acid that all vegetation needs amino acids to grow, and it has all of them in their leaves. So we use those leaves to make a tea to be an enrichment, a fertilizer. Okay, my partner here, Ken, is part of K Organics, and he's the one that introduced me to the Polonia tree and was suggesting I bring it up to you to see if it's a tree in your community that you can just find to get a cultivar of. Because
Um,
even if you just find the tree growing somewhere and you don't get it, you could go to just harvest the leaves, and those leaves are a huge nutrient benefit because of the amino acids
maybe,
it provides.
maybe I can get the seedling from the groups, the people that sell
Do we
seedlings.
mail them seeds? We could maybe mail you seeds.
Oh my God! Oh
I
my
didn't think
God!
about it.
Oh,
So you can in the LinkedIn you can send me your address, and I we can put some in an envelope and try to mail you some. I'm pretty sure that's a doable task. But it's
I'm
just
dedicating.
it's another diverse thing to add to your farm, but it can be used as a remediation tree. It creates shade.
Yes, yes, yes.
Yeah, and I
Uh,
can hear Ken here really wants to spend time talking to you as well because uh
I'm I'm enriching my
yeah.
mind
But so
more.
that's why I
So
say
as
we should create more of these conversations because
yes,
he has a
yes,
lot of
yes.
information that you
I'm
also value
interested.
from.
I'm interested. I'm interested.
Great.
You know, Mr. Tabor, as the director of a farm association and groups, and now exposing to government, it is very good for me to have ground to speak new things. And this also makes our association and farm unique from the rest. I'm proud I have a reason to allocate a plot for your name on our farm where we are going to plant those seeds. I'm proud. I will name it your name, and we shall introduce that plot for you.
Wow.
May I let you know that you are the first person putting us down for this kind of conversation. And yeah, I call it training, because if we are three, we are already taking a training. And IT has made the world one village. So you are the first one, and I'm going to write a report and give to the members. I'm going to brief them that we have started our conversation in this way, and we should prepare to start a project. This is going to be a project within Mamo Gardens.
Well, I want you to
So,
continue to document what you end up doing with biochar and tag
yeah,
us online and
I will
share it.
show you. I will show you what I have on the garden from Biochar. I'm going to show you even the crops we are going to grow. I will show you. I'm very happy.
I'm really happy too. I really appreciate that you reached out to me and shared your story. I think it's a beautiful story. I think it's wonderful what you're doing. is very
This,
honorable, is so
yes,
important. So
this
important.
cannot make me tired. It can't make me tired because,
No, it enlivens you, I'm sure.
yeah, I am
Yeah, well,
enriching my,
I tell you, once I learned about biochar, it invigorated me to want to tell more people
yes,
because once people learn, they too get excited. And once you understand that you are participating in the good, you don't have to know the whole story, just the part that is relevant. There's the part that you
yes,
need. If you need your quick removal of stuff, we can burn it, but have something at the end as charcoal. Or if you have a
yes, yes.
manure and a smell problem, well, let's make some charcoal so you can solve that problem
Charcoal.
and capture
Even
the experience.
this charcoal, if I go around where people are burning charcoal to sell in sacks for cooking, what they leave in the pits they have burnt the charcoal is a raw material for me according to today's training I've got. I can go and collect that.
Incomplete wood can still be burned into charcoal. So, like when I make, like in this picture behind me, where this stuff is incomplete, it's flaming. If I was putting it out to the end of the day, all those pieces I would set aside because they're not biochar. It's incomplete wood. It's incomplete char. But I can reignite it in the next burn. It's still burnable. It's just
Oh,
until it's crushed in black, it's just a biomass of wood. But once it's dry and black, once you understand the charcoal is complete, a test you can do with your bare hand is you crush it in your fingers. And if you can wipe your hand off in your pants or run it under water with no soap, if it washes off, it's good. If it's stuck on you like tar and you need soap to get it off, it's not done because it's oils.
yeah. So you find why I would like to say that those who burn charcoal for commercial purpose,
Mm-hmm.
what they leave behind in the pits are small pieces which they don't want to fill for the buyers because the buyers are interested in big volume pieces of charcoal. So you
Oh, I
find they have left
find
charcoal which can work for our purpose very well.
Gotcha. Because it's
We
already
go and
complete.
collect.
Yeah.
I will go and collect in sacks. I bring and add with what we have and use. So I will give you our address, postal address,
Okay.
mail the seeds. I'm very happy. Have a
That would
reason to
be fun.
celebrate the year 2026 in your name.
It's gonna be a great year.
Yes, it's going to be a great year. I will put it into full work because I can prepare these 3 months because this is a dry season. I will prepare this so that the first rain, which comes in the last week of March and the first week of April, I'm able to start using biochar nutrients.
This is exciting.
That
I'm
is,
so glad you got excited. I'm so
that's
glad you
what
reached
we
out.
are. I'm going to use the 3 months for making it. I will take pictures and share with you some snaps how I'm going about the process. I'll bring cow dung, the droppings of the cows and put. Then I bring for the goats. Even
So,
I'm going up to the human. The human remains the feces I'm going to use. I want to make that. And in the first rain, we are going to concentrate on food crops we are planting. We are going to plant food, corns, maize corns. We are planting
so
soya.
you get your first few batches of charcoal starting to enrich right away, so you can get some of that charcoal in with all that planting. Because that corn will
Yes,
do better with the charcoal in that plant.
yes,
Like you're planting seed, plant the charcoal
yes,
with the seed.
yes, yes. Even
The enriched charcoal, not the raw
the
charcoal.
corn, yes, the corn we throw away. I've thrown a lot of enrichments back to our soil. I threw away, you see.
You can make charcoal out of the corn cob, the corn husk, the
I
corn
didn't know.
stalks, all
I
of that you
did.
could be making into biochar. So
I
you can
was blind.
look around online for some videos of different kiln designs. The TLUD, that is a model to look at. It's a farm model that it's a 55 gallon and a 35 gallon drum, but you can light it and leave it and come back to it later. Whereas a flame cap kiln, you need to manage the flame. But usually stuff burns really fast. And once it's done, and if you make a pit, it doesn't need to be a 5 foot deep pit. It can be a 2 foot shallow pit. The scale of the pit is relevant to the amount of biomass you have. If you have a huge pile, dig a big pit. If you just have a small pile and you're just going to burn it up, by digging a pit, you're making an earthen kiln. Whatever's below the ground level is not getting as much horizontal airflow, so that you're reducing the oxygen from being able to bond with the charcoal to make carbon dioxide. But if you do an above ground pile with no pit at all, you'll get 10% charcoal out of the 25 that I said was available. But in a kiln or a pit, you can get 20% charcoal. Again,
I
we
need to get a
lose
pit.
5% to ash. We accept
I'm
that.
going to
But a
use a
pit
pit.
or a kiln or a barrel is really a worthy strategy.
You advise me to make a concrete pit. Do I make it a concrete or I make loose soil?
You don't need a concrete. I don't advocate concrete. You can mix concrete with charcoal if you ground it up to sand consistency and replace sand. You could use charcoal instead of sand in making concrete, and it'll be better concrete. Now, you can use existing concrete blocks, like a cinder block, and make a block kiln if you wanted.
Yes.
But you don't need to. You can, even with your sandy soil, if you can dig a hole, a pit, a cone shape. Again, it doesn't have to be a 5 foot pit. I dug 3 foot down and made 2 foot of soil above ground. So it became a 5 foot pit by digging a 3 foot hole. But you can dig 1 foot hole and have a 2 foot pit by 1 foot of dirt above. The idea is by having that below ground area, you're reducing the side air
Yes.
from coming to it, and you'll
Yes.
get more charcoal per burn.
Yes. Yes. In the
Once the
open,
pile is going
running
above
wind.
that, once the pile is above the pit, you're losing the effectiveness of it. You're getting more ash. So I usually would recommend go ahead and put it out. Stir it down to the bottom. Don't just ignore it. If it's 3 days later, a pile can go white. You'll never see smoke. You'll never see steam. It'll just go white. That's it converting to ash. So the few days after you make it, be very clear you're checking it every day that it's not going gray. If it's going gray, it's going to ash. If it's stale black, it's good to go. It can look white by the reflectiveness of the sun. So you might see a white spot on it, and it's actually just the sun reflecting on a shiny piece of charcoal. But gray is different than that. It's a very distinct ash color. If you see it, apply water. If you have a limit on water, you don't need, especially if you have a pit, you don't need the water. If you have a pit, you got that dirt you dug out, use the dirt and cover it and suppress it by putting it underground. And you can dig it back up several days later once you know it's cooled off. So if water's an issue, you can use dirt to quench it. But if you're making it in a season where you know rain's coming, well, then you'll have rains to replenish your quenching. But
This
yeah,
is good
you,
feeling
you
at the
just have
moment.
to lower the temperature. And the other thing we do out in our fields or practices is you rake it out. By raking it out so it's not in a pile, it doesn't have each other to radiate to keep the heat, so it can cool off quicker by spreading it out, especially in the end of the day and the cool of the evening or something. But
True. This is true.
yeah, so
I have a lot of
you
things.
have a lot of learning to do to figure out how to become a master charcoal maker,
Yes.
but I think you
Yes.
understand now the basis of it. It's
Yes.
simple.
Right now we are harvesting cassava, and the
Oh.
cassava stand is big volume, and we would have burnt this into free ash and throw away. We are going to cut this into pieces. I want to make charcoal out of the cassava stand on
Yeah.
our acre.
Because I
You
mean,
see?
I've made charcoal out of cardboard. It could be paper. It just needs to be learning that line between no longer flame, but not quite ash.
We were throwing away so many things. When we harvest maize, we remove the grains to feed our chicken. You find we are throwing away the remaining. We call it useless now to throw away. We burn to ashes and throw away. No, I'm going
Not
to save
anymore.
everything. I'm
So
saving
some
to
of the benefits for livestock to eat charcoal is it helps in their digestion because it absorbs toxins that they might have eaten. So it can help their digestion. It can provide air in there, just like in a compost pile for a ruminant. Having charcoal in their gut actually can improve their rumen function. Now, I had mentioned why I resist them eating it because of their teeth.
Yes,
But
you
what I
told
have
me.
found can really work well is you can actually soak charcoal in water and rinse off the fine flour charcoal. So if you just take your bag of charcoal that's raw and you dip it in a bucket of water, the flour charcoal, the thin pulp, the really fine substance of charcoal can become in the water and floating in the water, and you can stir it in the water. And so when it's in the water like that, my sheep would drink it, and now their teeth
Yeah,
aren't chewing it, so they're able to
well,
drink the charcoal if you're using that fine flour consistency, and it's in their water. And I just watched a video that said in China they've been doing this for centuries, where they soak charcoal in water to give to the chickens. So the
I
chicken's
didn't know.
water is actually charcoal soaked water. And so they're doing it because the chickens aren't going to chew a big chunk of char. So they just soak it in water so that the fines like you're finding at the bottom of the pit that they can't
They drink
market,
it.
that fine charcoal can be what you get into the water. And so black water of black charcoal is
Yes,
perfectly fine. But, black tar in water is gross, but the charcoal will stick to that. So any polluted water source at all, charcoal is the solution to that issue. So that's where we're putting a wattle at the overflow and at the inflow of any body of water that's gross. And a lot of them are gross because they're downhill from livestock that are poorly managed in many cases. So
I
you
didn't.
can, it's a real remediation strategy.
I
But
really didn't know. Never. I didn't know anything about that. And I want it into practice straight away for the
well,
chicken.
yeah,
Yeah.
yeah, absolutely. And document it.
Immediately.
Document that you're doing it so you can share it with your. Do you have a YouTube channel yet?
Yes, we have Mamo
Great.
Gardens
Well,
Model Farm
yeah, we
Initiative.
we have a YouTube channel as well, Biochar Coalition, so you can tag us or collaborate if you start doing anything with biochar. We would welcome promoting what you're doing to show the world that look, this is other people doing other things with biochar.
Yeah, if you would write it for me, I can go to sign
Sure.
in on you.
Yeah, I'll send you a link to our channel on LinkedIn. That seems to be where we've chatted, so we'll keep our conversation going
Okay.
there.
Oh, great.
And I'm
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 so glad.
happy to organize doing these meetings again if there's a specific time that's better for
Yes,
you. If you want other
yes,
people to
yes,
participate, you just let me
yes.
know and I'll try to
Okay.
calculate what time I need to
Okay.
meet you.
Okay. Beautiful. I'm happy.
Great, me
I've
too.
nothing to give you to reward you. I pray God bless you in everything you are doing. Your knowledge is wealth. I've seen the wealth. I'm starting to see the wealth in your knowledge.
I appreciate hearing that. It's very kind.
Thank you. Yes.
Great.
I'm
Well,
ready. I'm
it's
ready. I will be there.
great. Well, I'm really glad that we've started this conversation. I look forward to continuing it.
Okay. All right.
Do you enjoy your day? You have a whole day ahead of you.
I'm so happy. I'm enjoying my day.
Great. Well,
I've
I
enough to
bet the
tell you.
next person you're going to meet, you're going to start telling them all about
You
biochar. You're
you are
so
an
excited.
expert. You are an expert for Mamo Gardens Model Farm. Now, I'm going to minute it. I'm minuting it. I'm so happy about that.
Great. Well, I'm really glad you reached out, and we'll talk again. We'll stay in
Okay.
touch. We got
All
years
right.
ahead of us, but we don't need to
All
wait
right.
years. This year is going to be
All right.
amazing.
All right. Thank you. Thank you. Thank
Yeah.
you.
Yeah. Thank you.
Okay.
You have a great
Okay.
day.
Okay. Okay. Thank you.
Bye bye.
Bye bye. Bye bye.